Alrighty, so I guess as a quick introduction to what you're saying there, it looks like, were you on phone there?
Huh?
Were you on phone or laptop?
Oh, that's my laptop.
Laptop? Okay, cool.
Yeah.
So, you familiar with the interface for Zoom? All I'm saying is like, I've got a bunch of different cameras for my face, handwritten notes, and any of the digital notes. Can you see all those clearly enough?
Yeah, yeah, kind of can.
Yeah.
Maximize it.
And if you
Yeah,
need to
yeah,
maximize anything, obviously you can
yeah,
like pin it or whatever. Easy.
yeah.
Alright, so the agenda for this class is to go through how we sketch circular functions.
Yes.
So we'll go with that for a little while. If no,
Sorry, it's my dog.
yeah, you're all good.
It's my.
You're all good.
Okay, by the way, I'm doing 14A, B, C, D, E, and J.
Oh, look at that. That's actually really well. It's a little bit before what we're doing. 14 A B C D E J. So it is
Yes.
skipping the
Yeah,
sketching.
yeah. That's what
Um,
the test is gonna be about when I get back first week.
Okay, cool. So you'll like if you have a look at the past recording for like last week's class, you'll see us go through pretty much all of that.
Okay.
And I think J is the applications, isn't it?
Okay. Okay then. Yeah.
Yeah. So if J is applications, I believe that'll be next week's class if I recall correctly for this time slot. But yeah, there's plenty of past recordings on things. In fact, once we get you sorted with the modules, we'll unlock those, and then you'll have not just the class recordings, but also very like direct to camera scripted scripted sessions to see how those work.
Okay.
But okay, for this class, so looking at the screen share for now, I've got the Cambridge book open, but what we're looking at here is just some fundamentals around the sketching side of things. So I know it's not immediately relevant to you just now, but it will be very, very soon.
Okay.
So, first things first, the general form of a circular function. So,
Mm-hmm.
just like any other kind of function has a general form, so too does the circular function. You're going to have some dilation factors a and n. You're going to have some translation factors h and c. You'll probably be
Okay.
mostly familiar with those when it came to like quadratics or cubics, if you remember those. It's a very similar idea where your h is a horizontal translation, your c is a vertical translation, and the a and n are your dilation factors. So, basic form of sin x is going to look like this. It has a wave-like pattern. Have you seen
Mm-hmm.
any of this before?
Yes, I did it last year.
Oh, you've done circular functions last year. Nice.
Mhm.
Okay.
Yeah.
So this will be a bit of a revision then. Okay, so on the x-axis is the angle, so that's the thing on the inside of the circular function, and on the
Mhm.
y-axis, of course, is going to be the exact value that your circular function has. Its pattern repeats. The time in which it takes for the pattern to repeat is called the period of the circular
Oh
function, and
yeah.
it has a very
Mhm.
specific calculation,
Yeah.
which we'll get to in a bit. Cosine looks very similar. The only difference is that it's going to start at a peak, whereas this one started at a middle. Right, so you can see it goes middle, peak, middle, trough, and then continues, whereas this one starts at x equals 0, but the y is a peak value at that spot.
Mhm.
Okay, next up, dilation factors. So, just like you would for any other graph, a dilation factor out the front as a multiplier stretches the graph vertically. In the case of 3 sine x, what you're essentially seeing is that instead of it cutting off at plus or minus y equals 1, we're now cutting off at plus or minus y equals 3. That's all
Mhm.
that's happening. You
Mhm.
multiply that value, and that becomes your upper and lower bound of the circular function.
Mhm.
Also worth pointing out, this is sometimes referred to as the amplitude, although that's not necessarily correct. Are you familiar with that term?
Oh yeah.
Yeah. Do you know why this isn't the amplitude?
No.
Yeah, it comes to because the definition of the amplitude is the distance between the peak and the middle. And so the reason why this number isn't necessarily the amplitude is because the amplitude can never be negative, whereas this one can. Because by definition, it has to be a positive distance from here to here.
Oh yes. Yeah.
So if you have a negative, let's say this said -3 here, just want to clarify, the amplitude of that is still 3. The reason why I'm harping on about that, there was a multi-choice. Maybe I think it was actually last year's exam. It was in one of the multis, and it covered this exact topic. So worth clarifying that. Next is the dilation factor that impacts the x value. This is usually given the letter n, and it's going to stretch it horizontally, right? Or effectively halve the period in this case. You can now see it repeats from 0 to pi, rather than previously it was 0 to 2 pi. Okay, we've gone through this. Here's the calculation for period, usually given by capital T. And it's always going to be 2 pi divided by n, where n is whatever the coefficient on the x is going to be. So in this case, n would be 2. And so we can even do a quick little check to say, okay, if we sub in 2 in here, the 2's cancel out, you get pi, which sure enough makes sense for the graph that we have. One other thing that I like to explain when it comes to sketching circular functions is that all of the key features, we're talking like peaks, the troughs, and the mid-levels, they're always going to occur at quarter period intervals from each other. So what that means is, within a given period, basically every quarter of that, so in this case, if the period is pi, a quarter of a period is, a quarter of pi is a quarter pi. This is going to occur at 0, this is going to occur at pi over 4, pi over 2, 3 pi over 4, and then finally pi. So knowing that it's split in quarters makes it really easy for us to dot out what that circular function looks like. We're going to have a look at that now. So we're just going to sketch a simple example with just the a and n terms, those dilation factors. If those are all you have, then you're basically following these 5 steps here for any questions like it. Some of them you can do in different orders, like 1 or 2, it doesn't really matter what order you do them in. This is more so just to give you a general overview of like, hey, here's one potential way of doing it that works pretty well for most people. First up, let's figure out what the period of our graph is. In this case, we can see the n value is going to be 3, and so...
It's 2 pi over 3?
2 pi over 3, yeah, correct. 2 pi divided by n is 3. Next up, we'll grab our peak and trough magnitudes. So that's going to be whatever the a term is at the front, and you basically just slap a plus minus at the front of it. So peaks and troughs now going to occur at plus or minus 2. Next up, so this is where we understand, or this is where we make use of the fact that the key features occur at quarter period intervals. We're going to take that period that we just found and split it up into quarters. So we know that it's ending at 2 pi over 3, starting at 0. We're going to split this up into quarters. My preferred way of doing it is just halve it and then halve it again. So 2 pi over 3 halves to pi over 3, half that to pi over 6, and then you just sort of fill in the back at the end.
Okay.
Any questions on how you might fill that last spot in?
No.
Cool.
No questions.
Easy. And if anyone else has questions, feel free to raise your hand, hop off mute in the chat, anything like that's fine. Okay, and then all we're going to do now is figure out where the y coordinates are at these spots. So we're given the x coordinate of all the key features. We now need to know what the y coordinates of the key features are at those spots. So with that understanding, you have to now look at the basic graph of either sine or cosine. So in this case, we had cosine, and so we know that the first thing has to be a peak, right? For starting at 0, the first thing has to be a peak. So when we go through and dot it all out, I just realized I had a picture there for it. When we go through and dot it out, we know our peak value is y equals 2. So when we go to x equals 0, we put a dot at y equals 2. From there, we just go in order of the cycle. So from a peak, it has to go down to a middle, which means this value is going to be the middle. Then the next one's going to be the trough, middle, peak, and you might continue that if you had to do more than one cycle, but usually you don't. Once you have that all dotted out, you just draw a curve through it. Nothing too special, just try to get a decent curve. The whole point of how we've arranged this out is to try and maximize the possibility of your curve looking like an actual curve. I know it can appear bunched up in other circumstances if you just try to freehand it. But yeah, that's how you draw a simple cycle of a circular function with just a or n. Any questions so far? I'll pause for like a couple seconds. Alrighty. So I kind of pointed at this earlier, but not in too much detail, and that is that there's the possibility of having negative signs out the front of our circular function. So when we have a negative sign out the front of any function, it means a reflection, specifically a reflection in the x-axis, or about the x-axis, which simply means you flip vertically. All right, so peaks become troughs, middles are going to stay the same because they're already at y equals 0, and everything else is going to flip vertically. Which is why instead of, because we look at sine would normally go to a peak on its next thing. Because it's now a negative sign, it's now going to go down to a trough instead. Same thing with cosine. Cosine normally starts at a peak, now it's going to start at a trough, and then continue the pattern from there instead. Okay, next up, horizontal translations are also quite possible. Horizontal translations look the same as they have for other functions, namely like the quadratic, right? If you have like x minus h all squared, that would tell you the horizontal location of your turning point. In the case of circular functions, it gives you where the new starting point is going to be. So when you have x minus pi over 2, just like how minus means right in quadratics, it also means right in circular functions, which is why the 0 point, the starting point of sine, is now going to occur at pi over 2 instead of 0. Cool with that? Okay. If you have plus, then you go backwards. Right? Plus pi over 3 means we're now going to start at negative pi over 3 since we're shifting backwards by pi over 3. And because it's cosine, it's going to start at a peak. Right? Positive cosine always starts at a peak. We're just shifting where the x coordinate of that starting point is going to be. The y coordinate will always be consistent unless there's another thing which we'll look at in the next example. Okay, next up, an example. So I'm just slightly changing what we're seeing here in our framework. You'll notice a lot of things are the same, right? Steps 1 through 3 are all going to be the same. Step 5, step 7, those are all quite similar. Only thing we have to do now is when we create our when we figure out those quarter period intervals, we're going to now shift those either forward or backwards depending on which way our horizontal translation is pointing. The other thing that might come up now is that you might have to individually now find the y-intercept. So if you look at this example here, you'll notice that it cuts the y-axis, but it's not one of the key features, or at least not one of the key features we've seen from circular functions. It's not a peak, it's not a middle, it's not a trough. We now have to find this in addition to everything we've just done. That you solve as you always have. For any y-intercept, you set x equals 0, and you solve the circular function that you get from having done that. All right, let's put it together. So we're going to sketch this graph, 3 sine of x minus pi over 2, and we're going to do it over this particular domain. So period, peak and trough, nothing too crazy from what we did before. Period is 2 pi over n. In this case, n is 1. So just because there's no number written here doesn't necessarily mean there's no n. It just means that n is 1, because the coefficient of any letter is implied to be 1 unless otherwise said so. That's how I put in n is 1, period is 2 pi. Peak and trough are going to be plus minus the value at the front. That's why we have a peak of 3 and a trough of negative 3. Next up, split the interval up. We had a period of 2 pi. If you quarter that up, halve it to pi over 2, go back for 3 pi over 2, we've now quartered it up. Technically it's in 5 parts because 0 counts, but when you think about how you actually set up that interval, pretty much all you're doing is quartering the value that you have. This is where things get a little bit different. We had a horizontal translation, which was this one here, minus pi over 2. That means we have to shift everything that we've just done forward by pi over 2. So we take all those coordinates that we have, and luckily enough, pi over 2 is a nice value, right? Because all of these already do have a base, a common base of pi over 2, and so when you shift pi over 2 forward by pi over 2, you hit pi. So we can actually reuse a lot of these ticks and pretty much only delete the 0. That becomes your new, pi over 2 becomes your new starting point, and then we go 1 forward from 2 pi. So you would convert 2 pi to 4 pi over 2, and then add up to 5 pi over 2 in that case. This is our new distribution. Now from here, again, we look at whether we had cosine or sine. In this case, we had sine x, which means that our new starting location is going to start at 0, because sine always starts at 0. It is positive sine, so we're going to make the next value, or the next x-coordinate, a peak, and then from there the rest of it becomes self-explanatory. You continue the pattern to make that wave that we're already familiar with. If you need to find a y-intercept, you would have to substitute x equals 0. In this case, our domain is all the way out here, though. We're not actually touching the y-intercept, and so you wouldn't go ahead and solve that. Well, we'll see an example, I think, where we do a y-intercept, but just not this one. And then, yeah, just draw a curve connecting all those points. How's that? Any questions so far? Alrighty, and if I'm going too fast at all, just someone speak up or put in the chat. More than happy to revisit anything. The last complication is vertical translations. So what you can think of as what a vertical translation does is set the new mid-level of your circular function. So normally it would be between like plus minus 1, plus minus 2. It'd be symmetrical about the x-axis. Now it's being shifted up by or down, depending on what if it's positive or negative, by whatever that value is at the front. In this case, it's plus 2. And so what you're essentially doing is now saying the middle level of my circular function is now y equals 2, rather than y equals 0. Depending on how far you shift up or down, it may make it easier, it may make it harder. In this case, if you shift it entirely up, it actually makes your life a little bit easier, because now you're never touching the x-axis, you never have to find those x-intercepts. You just go with it from once you find your interval ticks. However, if you are unlucky, which is in most cases, you might also now have to figure out additional x-intercepts, because it now cuts off at different spots. This one was shifted down by a half, which means this is our new mid-level. And so you can see if you quarter up the period, you've got 2 pi, pi, pi over 2, and 3 pi over 2. You've got those quarter intervals going on. There's also these two key features we now need to find additionally, which makes life a little bit harder. It only just takes a bit more time. You don't have to do anything actually different. It just means you have to sub y equals 0 and solve the circular function like you would have done. Well, for those who were in the previous class last week, we looked at how to solve circular functions. And if you're more or less going through that recently, we'll also catch you up on that. But okay, this is your worst case scenario, basically. You've got vertical translations, horizontal translations, and yeah, I mean, there's always an amplitude, there's always a different period, so that's pretty much a given. It's more so whether you have vertical or horizontal translations. So what's going on differently here? Well, a lot of this is going to be the same. In fact, almost all of it from 1 through 6 is the same, except now I've added this additional step, which is if you need to find your x-intercepts, which is y equals 0. So let's give it a shot. Negative 2 cos x plus 1. And we're going to sketch it from 0 to 2 pi. So period, that's easy. N is 1, so period is 2 pi. Peak and trough is actually now a little bit different. I didn't necessarily explicitly say what was going on there, but the peak and trough, because your middle is now shifted up a little bit or down a little bit, in this case it's up by 1, the peak and trough are now going to still be plus or minus 2, but you're going to add 1 to both of those circumstances because now it's shifted up a little bit. So you're now having 1 plus 2 and 1 minus 2 as your peak and trough values. So this one's going to have a peak of 3 and a trough of negative 1. So basically the midline would be this, the peak would be this, and the trough would be this. Dividing up the period, so we knew it was 2 pi. Quartering that up gets you this spread that we've seen before. If there's a horizontal translation, you've seen now how that works, but in this case there was no horizontal translation, so we'll be happy to leave this where it is. And then all we do is we plot out the dots. So we had negative cosine, which means it starts at a trough instead of a peak. Then the next will be a middle, the next will be a peak, the next will be a middle, the next will be a trough. So you always, whether you're at peak or trough, the next thing will always be middle. And the values change ever so slightly because we know our trough is -1, we know our middle is now 1, and we know our peak was 3. We calculated all those from earlier. Now, when we draw the curve, we'll realize, uh-oh, there's more things to solve. So I guess I'll pause here. Up until now, any questions so far on how we've achieved that? Okay. Next up, so how are we going to find these x-intercepts? Well, we set y equals 0. So this was our function, that was the thing we're trying to graph. Set y equals 0, and then solve that circular function. So in this case, it means subtract 1 from both sides and divide -2. That's going to get you cosine equals a half. So we just got to figure out, where does cosine equal a half? Now, at some point, you do need to have your unit circle memorized because it is a requirement and it doesn't get to appear on your formula sheet. So this is going to be your Bible, basically, for anything circular functions related. The way you use it, for those who aren't too familiar. For cosine equals a half, since the angle is the thing that's unknown, you basically want to look around on your unit circle and figure out which of these angles on the inside is going to give you a value, one of the coordinates of, in this case, x equals a half. And the reason why is because cosine is your x coordinates. And so you want to figure out where are all the spots on the unit circle where the x coordinate is a half. That's going to be those two spots there. It's going to be your pi over 3 and your 5 pi over 3. Does anyone need me to go through that in any more detail? Those are your x coordinates. And so that means your solutions are therefore pi over 3 and 5 pi over 3. You're just going to label those and then leave it be. That's pretty much it for the lecture section. So we've looked at how to handle all different terms that can come up when having to sketch circular functions. I've given you a few different frameworks and evolved them over time for different complications, whether you have different terminologies or different terms to work with, basically. Because it's all well and good to give one thing that works for everything, but it's also pretty heavyweight. You don't want to make too many decisions. So this sort of breaks it down into the individual bare bones necessities for sketching those types of graphs. Okay, so what I'll do is, just to have reference to it, I'll do a screen grab of the unit circle. So when we go through some questions, it'll be useful for you to have access to. You won't need the tan one because we're just doing sine and cos. Yeah, all right. I'll pull up some questions and we'll go through them together. While I do that, feel free to let me know if you have any questions as to anything we've covered. All right, I should probably grab these as a screenshot as well. If this is too zoomed out for the screenshot, let me know. I'll do it in 2 parts. So let's start with 4a. So I'll just turn the phone back on, and now we'll pretty much work out of the digital notes now, the handwritten stuff. Turn it back on, and we'll start writing it out. So 3 sine 2x. 3 sine 2x. That's what we're going to sketch. How should I start this off?
Do you start off with an amplitude?
Yep, sounds good to me.
Yeah.
What should we do?
And then do the period, like 2 pi over n, which is like 2 pi divided by 2 is just pi.
Yeah, correct. So we could do, so amplitude we know is 3, so we could say A is 3. Period, as you said, so period is 2 pi over n, where in this case n is 2, which is why putting a 2 in that spot, period is therefore pi. Very nice. Okay, once we have those, what should we do after that?
Do we divide it by 5?
Divided by 5. So we'll split it into 5 equal parts, yes,
Yeah.
but you won't be dividing the value by 5 necessarily because 0 is going to count as one of your spots. So when
Oh,
you split it into, when you divide by 4, you are still getting 5 points, which feels a bit counterintuitive, but you'll see what that looks like.
okay.
So if I go out like this, a full cycle is going to occur in pi. And so when we start splitting that up, right, divide it into, divide it into again, and then go back to grab this one, we'll be counting 4 spots here, but this 0 also counts. So between 0 and pi over 4 is a gap of pi over 4. Between pi over 4 and pi over 2 is also a gap of pi over 4, and so on until you get all the way to the end. So even though we do want 5 spots, we are dividing by 4 to achieve that. Fair enough? Cool. So that gets us our X array of what's going on there. Once you're caught up on copying that down, what do we do next?
We gotta find the peaks and troughs.
Peaks and troughs, absolutely. Yeah. How do we get those?
Plus and minus A.
Plus minus A. Yeah, absolutely. So what does that tell us about the peaks and troughs right now?
The peak is 3 and the trough is -3.
That's it. Yeah. 3 and minus 3. Absolutely. All right. What do we do with all this now?
We plot the points.
Plot the points is correct. Yeah. So basically we'll try and go horizontally from left to right and we'll figure out what each of these dots are going to be, whether they're middle, trough, or peak. So starting at x equals 0, reminder that we have sine, we're sketching sine. Where does sine start at x equals 0?
In the middle.
In the middle, yeah, correct. That's it, so we'll draw a dot there. Next up, pi over 4. We'll be going to, what's the pattern continue into?
Is it peak, mid, trough, mid?
That's it, yeah. Peak, mid, trough, mid. And then, yeah, the rest of it's not anything crazy. We just try to, well, we try to sketch it out without it looking too bad. That might be one of the better ones I've done, actually, which says a lot. Yeah, so we just continue the pattern from there. The key thing there was figuring out, do you go up or down from that starting point? Now, ideally you just have this memorized and then it's all good, but the real world isn't necessarily always ideal. And so a fallback strategy that's worth remembering is you can actually figure out any of these coordinates, any of these y values, by plugging in the associated x value into the function. So I'll show you what that looks like, just in case anyone wants to use that tactic. Let's say we don't remember if we go to peak or trough on pi over 4. Well, we have our y equals 3 sine 2x, or in this case, we're going to plug in x equals pi over 4. We then have y equals 3 sine 2 pi over 4, which is just pi over 2. Does anyone remember what sine of pi over 2 is? One is correct. Yeah, thanks, Peter. And so we replace sine of pi over 2 with 1, and then obviously 3 times 1 is 3, which sure enough is the value that you put at that spot. So if you ever forget your shape, you can always fall back on doing that. It'll take you a few lines of working, sure, but it's better than not getting the question right at all. So there's some error checking for yourself. Otherwise, yeah, that's a pretty fundamental example of just doing your A and N values. Different period, different amplitude, different peaks and troughs. If there's anything to clarify, be sure to let me know. Otherwise, I'll pull up the next complication. Yeah, okay. Instead of doing another graph, what I'm actually going to do is change the domain on us slightly. So instead of going from 0 to pi, we now want to go negative pi to pi. So I've got to give myself some space for this actually. So let me see, can I grab all of this? It looks like it. All right. Now we don't care about just doing one cycle. We want to do multiple cycles, ending at negative pi. I haven't actually explained how we do this, although I'm curious to see if anyone can come up with a way of getting us all the way to negative pi.
Would you just like reverse the x values?
Yeah, reverse the x values. So what does that mean our x values are going to be?
Negative pi on 4, negative pi on 2, and I think it was negative 3 pi on 2, or 3 pi on 4.
Which one do you think, based on the pattern?
3 pi on 4?
Yeah, negative 3 pi on 4 is good. That's it. And then as far as not only do we reverse the x values, but we're also reversing this pattern that we just had. So if we imagine going backwards on this, what should the next thing be? A peak, middle, or trough? We're talking about like this negative pi over 4 here. Would it be next to the negative 3? Yes, yes it will. So the y value will be negative 3 at this spot because you've gone from, oh, I just realized I didn't even put a, maybe I left it behind. Yeah, I did. Nice. Yeah, because this was a peak, this was a middle, and so going backwards we would expect a trough, and our trough is negative 3. Then going backwards we would expect a middle, peak, middle, and this is basically your way of handling different domains. You always start by sketching a full domain, or at least dotting out a full domain. Then it doesn't matter what your domain says. Like in this case, we've sketched negative pi to pi, but what if it was like, I don't know, let's say negative pi over 2 to 3 pi over 4. Once you have your cycle, you can just go forward and backwards in any amount that you need to in order to sketch what you need. So in this case, we're cutting it off at negative pi over 2. We don't want any of this, and 3 pi over 4 means we don't want any of that. So you can try to think about it ahead of time once you start getting really good at sketching, but even at my level, I'll still be just doing one cycle of the circular function and then erasing or adding bits as necessary. but okay. Now, I think that's about as many complications as I want to touch on there. We looked at different domains, which therefore meant different number of cycles. Yeah, that covers all the A and N stuff. Moving on. Horizontal translations now. Okay. Let's go with, in fact, yeah, we'll even chuck a reflection in there as well. I'll change this one up a bit though, just so we don't have a super nasty. Yeah. Okay, let's change this one up a bit. So we're going to have y equals -3 cos, and then theta plus pi over 2. Alright, so we're dealing with horizontal translations, and we're also dealing with a negative in there. What shall we do? Some things never change when it comes to sketching circular functions. A lot of the steps will be consistent no matter what terms we have in there. So based on what we've done before, what do you think is going to be required here? A lot of it will be the same. There's also a screenshot in there. Oh, yep, period and amplitude, correct. Yeah, let's grab those. So let's start with period. Why not? Period is what? Or how do we calculate it?
2 pi on n.
2 pi on n, yeah. So the next natural question to that would be, what is our n value? Is it 1? It is 1, yeah. So any coefficient is always going to be on the x value, or in this case, it's written as theta. And if there's no number there, it's implied to be 1, not 0. Okay. 2 pi on 1, which of course is just 2 pi. Okay, that's that. Amplitude. Now, we'll use a loose definition of amplitude. What's that going to be? A equals 3, yeah, okay, so that's fair enough. We could use the proper definition of amplitude, making sure we leave it as positive. Yeah, thinking of this negative rather as a reflection term. Yes, amplitude is 3. Cool. Now what does amplitude help us actually get for the sketch of a circular function?
Peaks and troughs.
Peaks and troughs, absolutely. So what does that tell us about the location of the peaks and troughs?
Peaks it like tells us the highest point, and troughs it tells us like the minimum.
Yeah, that's correct. And what values do we know they have to be?
Like -3 or +3.
Yeah, -3 or +3, absolutely. That's it. So we can get those on our y-axis. Cool. All right, we're starting to put together a few key features. What else can we put onto this axis? Do the scaling? Yes, absolutely, we do the scaling. Question now becomes, how do we do the scaling? How do we start that up? 2 pi and divide by 4, correct. Yeah, so 2 pi, our period, which is our end location for a full cycle, and then dividing that by 4 gets us our 4 equivalent values. So halve it again, and then 3 pi on 2 will be that final value. Not forgetting, of course, that x equals 0 is still in there. Okay, this is where things are going to differ a little bit. So if you're following the guide, you'll be able to spot that immediately, or if you've otherwise remembered it. What do we have to do now that we have this initial scaling?
You have to plot the points.
Plot the points is a little bit premature. So have a look at the function again. What's one term that we haven't considered? Because I'll say plotting the points is like the last thing you do, because then you can draw the curve. We haven't considered every single term that's in there though. And yeah, P has got it there, which is the translation of pi over 2. Which way are we shifting? What does plus pi over 2 mean? Yeah, negative direction. That's it. So it means all of these values, x values that we just found, have to now be shifted backwards by pi over 2. Now, that's kind of fine for us because all these already are separated by pi over 2. So basically, all that ends up looking like is our endpoint is no longer at 2 pi, but it's backwards by pi over 2. So this spot. And then our starting point is now, I should probably have given myself more space for that, but I guess we'll make do, is now negative pi over 2. So if you imagine having shifted all of those backwards by pi over 2, this is what the net result would be. You have negative pi over 2, you have 0, pi over 2, pi, and 3 pi over 2. From end to end, that is still a period of 2 pi. Each of these are still quarter period separated from each other, but they're now just shifted back a little bit. Now we can do those dotting, we can dot out the points because we've hit every term almost. We hit this one, we hit this. The only thing that's left to hit is the negative. What does that imply about how we dot this out?
Start at the trough.
Start at the trough now, yeah, because cosine will normally start at a peak. Reflection means we're now shifting it down to starting at a trough instead. Then the rest of it becomes pretty natural to fill out. Trough can only go to a middle, and then it can only go to a peak afterwards. And so on and so forth. I totally missed the dot, but I'm sure you get the point. This is supposed to touch that. You know, it might even be easier to, because if you use a pencil, it might even be easier to get a rough idea, draw it, and then redraw the ticks afterwards, just so you can put them in the right spot. Up to you. Yeah, so I didn't really touch on it last time, but you could also, if you really wanted to be super sure about your sketch, you can also put in the endpoints as well, even though they are implied by having the coordinates labeled like this. You can be extra careful by actually labeling them as well. 3 pi over 2 comma negative 3, for instance, and then this one over here, negative pi over 2 comma negative 3, if you wanted to be super sure about that. We don't do peaks, we don't do troughs. Then the reason we're doing these troughs is because they're endpoints. So minimum standard for any sketch is you need to do your axes intercepts, and you need to do the endpoints of your graph. Anything else will depend on what type of graph you have. Yeah, that's it. Cool. So that's that one sorted. Crushed it. Okay, if there's anything to clarify there, please let me know. Otherwise, we can go to the final complication, which is adding a vertical translation to the graph. Oh, look at these nasty question 3s. Let's yeah, let's only do a vertical. Let's not have a horizontal when there is. Yeah, let's only do a vertical. Okay. And I think in the video lectures that I have that are scripted, and in the note, well, no, just the video lecture has one with both in it. So feel free to use that if you want to really go above and beyond. But for now, y equals 2 sine 3x minus 2. Yeah. That's all the same anyway. even if it's not what the book says. Come on, focus in. Cool. Okay. Got a vertical translation to worry about. Again, steps are going to be largely the same. So how might we start this one out?
Like we have to lower the graph by 2.
Lower the graph by 2 is correct. Yeah, absolutely. So when we get our, if you want to go straight to the axis, it means lowering the graph by 2. What does that like mean as far as me writing things on the axis?
Like the amplitude and the amplitude's going to change.
Amplitude. Just to be technical with the language, the amplitude doesn't change, but the peaks and troughs change.
Yeah.
Which I think is what you
the
meant.
peaks
Yeah.
and troughs.
Yeah, I think that's what you meant, but yeah.
Yeah.
Okay, so what does it mean our new peak and trough is going to be if we know they're going to change? Wait, write these out actually. Peak, trough. What are those actually going to be now that they've been shifted down?
It'll be 0 and -4.
0 and -4, yeah. Because you have, starting at -2, you do +2 for the peak, and starting at -2, you do -2 for the trough. So that's going to be the 0 and -4, just like you said. Cool. That's going to be a 0 there, and let's draw this a bit lower, -4 there. Okay. Cool. What else do we need to know?
Period is 2 pi on 3.
Period is 2 pi on 3, yep, because that's our n value of 3 there. Capital T is 2 pi on 3. Cool. All right. What else?
Just write up the graph.
Yep. Right up the graph, absolutely. So we've got to do the scaling on these. So what do the ticks look like?
So the furthest one is 2 pi on 3.
Yep.
Is the first one going to be like pi on 6, like after dividing it by 4, excluding the 0?
Yeah, correct. So this one's going to be pi over 6. And yeah, the way we get there, you could either go straight by divide by 4, or you could halve it and then halve it again. Put 2 pi over 3 to pi over 3, and then half to pi over 6. Last one here. Little pro tip, it always takes this. Wait, does it always? Yeah, it always takes this denominator. It will simplify sometimes, but this will be the base denominator that you could get it into. I don't think I explained that well. So basically what I meant by that was like quarter period means that whatever this number ends up being is the separation between all of these. So like for instance, pi over 6 plus pi over 6 gets you to 2 pi over 6, which is pi over 3, plus pi over 6 again, plus pi over 6 again. They'll hit all those values.
Would it be pi on 2?
It is pi on 2, yeah. I always found this specific period of 2 pi over 3 to be the weirdest one, because it feels like everything in there doesn't quite look right, but it does end up. Yeah. Sweet, alright. Scalings are sorted. Pretty much hit everything. There's, by my count, only one thing we haven't labelled on the axis yet before doing the points. What's missing?
The -2?
The -2, yeah. So this -2, what does that actually tell us? What do we put on the axis and what does it represent?
That's been translated down by 2 units?
It has been translated down by 2 units, yep. And so how do I represent that? By drawing something on this axis.
What do you mean by that, Chris?
Okay. So as in the fact that it's been shifted down or translated down by 2 units, that's going to impact how I draw this graph. My question is, how do I actually show that on this graph? What am I doing? What does this piece of information tell me about how I draw my graph?
I should start at -2?
There you go. Yeah, start at -2. So in my language, I would say it is the new mid-level of the circular function, the new middle point of it. But yeah, for sine, starting there. Yeah. Cool. So yeah, we've already said it's going to start there, so we can put our first dot there. Now, do we go to a peak afterwards or a trough afterwards for this graph?
A peak?
A peak, yeah. Positive sign means peak afterwards. And then everything else is, well, as we're already used to. When you're fully above or below an axis like this, or mostly above or below, it can help when you're freehanding this on with a pencil. So just sort of do like a little grid line up and down it. That way you don't go too far removed from your tick intervals. And even if you're using if you're using graph paper, like the grid paper, that's like by far the best way to do these sketches because you can use the box ticks as your or the box spacings as your interval ticks, and you'll pretty much never draw a bad graph. I just happen to. Maybe there is a OneNote setting for grid lines. There probably is. I just haven't looked. Yeah, okay, that's pretty much it then. So sometimes, depending on your vertical translation, you might also have to find the x-intercepts. And if you have a horizontal translation, sometimes you'll have to find the y-intercept as well. I believe... No, did we do one for y? We did something. Oh, right, no, I showed you a fallback strategy for getting the value, which was just subbing in any x value. Yeah, so that's this one in particular. We do still have a bit of time left over, so what I'll do now is I'll add a bit more of a complication to it, which is... Oh, geez, now I've got to erase all those little dots. Which is what happens when it's not as neat, necessarily. So even if we just make this a... Now I've got to pick this carefully. I think -1 works. So -1 means we're now going to have -1 for those 2 spots. It's going to be a peak of 1 and a trough of -1. Hang on, no, trough of... What am I saying? Trough of -3. -2. -3. Going to have a peak of 1. I'll just fill out the graph real quick. And the reason I'm doing this one is so we can have a look at what happens when you have to now find the the axis intercepts.
Chris, you know the thing with A plus or minus C?
Yes.
Do you use it when there's a what do you call it? Vertical shift?
Technically you always use it, but the C value is 0 if there's no vertical shift.
Oh, okay.
Yeah. So in the simplified form, if there's no C, you just, you don't look at it. Because there's always this implied +0 in a graph, which is why the middle is 0 in most circumstances.
Yeah.
-3 here, -1 there, and then for sine, it's now going to be bang, 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 bang. This is probably going to be really messed, but it's fine. All I want to do is say, cool, now when you get to this stage, what do we do to find those? Yeah, that's correct, Pierre. Make y equal 0. Absolutely. Y equals 0 is always your x-intercepts. So we have 0 equals 2 sine 3x minus 1. 2 sine 3x minus 1. I had to be careful with this value because we do need an exact value to make this doable tech-free. Question now is, how do we solve this? We saw at least one example of that today in the pre-written notes. Move once the other side is correct. Yep. So we're going to start by putting a 1 over there. 2 sine 3x. What else?
Sine 3x equals a half.
Yeah, that's it. So overall, our goal was to get the circular function on its own and one of the unit circle exact values on the other side. Circular function, exact value. Okay. Now, how do we now solve this? Now that we have it. Got the unit circle up on the screen, sure, if you want to have a look at it. That or the screenshot.
We find all the y values on the circle which equal a half.
That's it. Yeah, all the y values that equal a half. That's going to be...
Which is pi on 6 and 5 pi over 6.
That's it. Pi on 6, 5 pi on 6. So pi on 6, comma 5 pi on 6. Those are the values. It's always worth checking when it's sketching. You check domain as well. So this is from 0 to 2 pi on 3. So you just want to make sure that the values you pick, you don't go too far. But the good thing with sketching is you can actually just see how many solutions there are. We expect to have 2 and no more. And so when we get our 2 values, as long as they fit on the axis, we're pretty happy with what we got. But the question is, are we done? There is a bit of a complication with this particular circular function.
Would you do 3x equals pi over 6 and 3x equals 5 pi on 6?
That's it. Yeah, we put 3x there because whatever's on the inside is what those two things equal. And so if you want to bring it home, what's the last thing that has to happen?
Pi on 6 divided by 3.
Yep.
And yeah, just divide both of them by 3.
And then 5 pi on 18. That's it. So this one here is pi on 18. This one's 5 pi on 18. Those two values. You can see it gets quite messy. So one of the ways I'd recommend doing it, if you're doing it by hand and you feel like it's like sort of cramping up, is I'll do all the interval ticks like maybe below the axis, and I'll do all the intercepts above the axis. So you can do your 5 pi on 18, pi on 18 there, and that way the neighboring values don't take up too much space on your thing. I know I cheated a little bit by zooming in. You can't quite zoom in if you're doing it by hand, but you can probably see how it's a bit more space efficient to do it that way. Yeah, that's that. Only other complication we didn't see is when you have both horizontal and vertical, but you've seen how to do horizontal, you've seen how to do vertical, just smack them together. Same things you've seen before. All right, so if there's any further questions, I'll stay behind for a little bit. Otherwise, I'll let you enjoy the rest of your day. Take care, guys.
Thank you.
Yeah.